Hello and welcome back. Mr. Wakefield looking at section 8.6 now with you. And we've seen in the last few videos, we've seen linear equations and quadratic equations. The thing about linear and quadratic equations is that they have polynomials on each side, or at least they do after you clear out some parentheses, okay? They'll have polynomials on each side. What's different about these equations, okay, and it says equations with rational expressions. You may remember from a previous video a while back that rational expression is just simply a fraction. It's a fraction that has a polynomial on the top and bottom, but the entire fraction is not a polynomial. It just has polynomials on the top and bottom of it, okay? And so because of that, when you have a rational expression, a fraction, where you have a variable on the bottom in particular, okay, that's not a polynomial, and therefore it's not. It can't be linear or quadratic unless it's a polynomial on each side first. Okay, so the basic idea here is that when you have fraction equations, you guys, equations with fractions in it, which is what all of these are going to be, okay, here's what you want to do. You want to get rid of those fractions, and that's the toughest part of the problem. I'll show you carefully how to do that. But you want to get rid of the fractions first. And then once you do that, the problem will automatically become either a linear or quadratic equation. Okay, and you'll see that in each one of these problems. So that's the key part then, is to get rid of those fractions, because once it becomes linear or quadratic equation, as you can see here in the second step, it says solve the resulting equation using techniques that we learned previously. Since the equation is going to become, either linear or quadratic, you just have to use the techniques that we learned for linear and quadratic equations. All right. So that's the easier part of the problem. Then there's one key part at the end. I'll talk about that though when we get to it. But the key part here that we haven't seen yet in any problem is this idea of getting rid of the fractions in these equations, okay? Because it's going to make it a lot easier due to the fact that the problem, again, will transform into an equation that you already know how to solve, because it'll either be linear or quadratic, okay? So how do we get rid of those fractions? What we do is we figure out what the LCD is of all the fractions that you see in the problem. Okay, here we've got two fractions, so we got to figure out the LCD. I think you can see what it is already, but I'll mention that here in a second. And we multiply both sides of the equation by that. That's where you got to be really careful, okay? But whenever your two denominators are the same, and those are the only two denominators you have, the LCD will also be that same thing, okay? There's no reason for it to be anything else, okay? The denominators are the same. So it says multiply both sides of the equation by that LCD. How do we do that? Well, here's the thing, and you'll see this a lot. If you have a fraction being added to a regular term that's not a fraction, or in the case over here where you have a fraction being subtracted with a regular term that's not a fraction, in each of those cases where you got a fraction and a regular term with a plus or minus in between those things, okay, what you do is you multiply by both of those things. All right, and so I need to multiply the x by 11 over x, the fraction 11 over x. Now, when you multiply by a fraction, you want to make the LCD into a fraction also. We've seen that in the past, where when you're multiplying by a fraction, you want to make the thing that you're multiplying a fraction also, so that you can then multiply the fractions. You then bring down the plus that's in between, and then if you now need to multiply by the regular term. But since it's just a regular term, you guys, you don't have to say x over 1 on this part, okay? Just on this part, because you were multiplying by a fraction. So here you just have to say x times 3, okay? Don't need to say x over 1. It's not necessary. Now, since this is a fraction here, and it's just a single fraction, it's not a fraction being added or subtracted to something else, it's just a single fraction, then we just multiply that one thing by x. And since we're multiplying by a fraction, I actually write it as x over 1. Here's the LCD right here, and I'm going to multiply it by negative 10 over x. I put the bracket there just because that's a negative fraction, and so When we multiply by a negative, you normally put a bracket around the negative. Okay, it's just how it's written. So what this does, and you'll see this on just about every problem that you do, just about, is this leads to 3 different multiplications. We have to immediately do these 3 multiplications in order to get rid of those fractions, and this will work. It will get rid of them. And then at that point, you'll then either have a linear or quadratic equation, and you'll be on your way. Okay. So how do we figure out what these things are equal to? These 3 things I circled. Well, back in the fraction chapter, we learned how to multiply fractions together, okay? And if you have a single term on the top and bottom, which we do in a couple of cases here in the current problem, you just start canceling right away. You don't have to do any of this factoring stuff like we did over here, okay? If it's a single term in all 4 places here, you just start canceling. And so we do that with this problem here, or this thing I circled here, because all 4 of these things are just single terms. Okay, what can I cancel? And don't ever cross cancel over the plus sign over the or over the equal sign. Just when you're multiplying do you cross cancel. Okay, since we're multiplying these 2 fractions, that's why I'm allowed to cancel the x's right there. All right, and what does that leave me with here? What should always happen when you have a fraction times a fraction in this step of the problem here, this first step of the problem, what should always happen is that the bottom should be 1 times 1. Okay, if it's not, then you're not going to be able to get rid of the fraction. Because what is 1 times 1, you guys? It's equal to 1. And what happens when the brand new denominator is 1? It means you don't have to write it, and the fraction is essentially gone. Let me show you. 1 times 11 over 1 times 1. That would be equal to 11 over 1, right? And what's 11 over 1? It's 11 because you don't have to write the 1 when it's on the bottom. So we got rid of the fraction. All because you have 1 times 1 on the bottom. Okay? Bring down the plus. And x times 3, there's no fractions there, just multiply it like you normally would. X times 3 is 3x. Okay? And then same thing here. There's a single term on the top and bottom. Okay? On the top and bottom in all 4 places here, that is. And so you can just start canceling right away. You don't have to do that factoring stuff. We'll see that. We'll talk about that a little bit more later here. So x and x cancel again, right? And you end up with 1 times 10 and 1 times 1 on the bottom. And be careful here because of this negative. Remember, this is a positive fraction times a negative fraction. So whatever you get, it's got to be a negative. And so 1 times 10 and 1 times 1 is 10 over 1, which is 10. But since it's positive fraction times negative fraction, we need to say that it's negative answer. Okay? And as you can see here, the fractions are gone. But you can also see that because it's not x squared, it's just x. There's no x squareds or x to the third or anything like that. And there's no parentheses. It's just a polynomial on both sides with just the x to the first power. That means it's a linear equation, not a quadratic equation. We know it, if we do it right, we know it's going to be one of those 2 things when the fractions disappear. Okay, you'll get either linear or quadratic, like we said. So I solved this. Since it's linear, as we learned back in chapter 3, okay, near the end of the last worksheet packet, you move the 10 and the 11 to the opposite side of where the x term is, and then when you got a single variable term and a single constant term, that's the step where you divide out like that. Okay, and you get -7. Now don't circle that yet. There's one more thing I got to talk about that's a little bit different than normal here. Okay, when you have an equation with a fraction, and in particular, not just a fraction in the equation, but a fraction that has a variable on the bottom. Okay, this doesn't happen in a lot of problems, but it does happen in enough of them that you need to remember to do this. In the last step of the problem, after you get x by itself and you essentially solve it, you need to check your answer, but you don't need to check it in the normal way by taking the -7 and plugging it back into the original equation to see if the 2 sides are equal. Okay, if you did all these steps right, okay, that's that'll be taken care of. All right, that's not going to be a concern. What is a concern, though, and this would also come up if you did plug them into the original equation, but this is all you're going to have to do, what I'm about to show you, though. You don't have to figure out if the two sides are equal. All you got to do is take the -7 and plug it into the denominators that have the variable in it, and see if the -7 makes the denominator equal to 0. Okay, if I plug the -7 into there, it obviously makes the denominator -7. We don't care about the 3 because there's no denominator there. We're just concerned about the denominators in this last step. Okay, if I plug the -7 into there, it makes the denominator -7. And if I plug it into there, it also makes that denominator -7. Okay, as long as it's not 0, as long as none of the denominators become 0 when you plug in the answer into the variable, all right, then you're good. Okay. When you have a 0 denominator, as we learned in the graphing chapter, that's an undefined answer. Like when we were talking about vertical lines, we learned that when you have a 0 denominator, that means it's an undefined number, and therefore it was an undefined slope, and it was a vertical line and all that. Well, it's still that's still true now. If you have a 0 denominator, you can't have an answer. Kind of like we saw in the last couple sections in Chapter 10, where we said that if you've got a radical with a negative underneath it, you can't have an answer, right? Okay, when you have a square root with a radical underneath it, it's the same idea here. You can't have 0 denominators. But the problem is that if you do all these steps I'm showing you here, they're all wonderful, these steps, but the one flaw that these steps have is that they sometimes do not prevent a bad answer from coming into your final answer down here. Sometimes you'll get an answer that's not really an answer because it makes the denominator equal to 0. It didn't happen in this case, as we just found out. -7 is fine, but sometimes it does. And so you still have to do that final check. Now, you only have to do that with equations that have fractions in it, especially if they have variables in the denominator. And there's also one other type of equation that we'll see in the next video where you have to do that. Okay, but you don't have to do it in a normal linear or quadratic equation where the original problem is a linear or quadratic equation. Okay, then you don't have to do it. All right, but you do need to do it, and remember this, okay? It's an easy thing to forget. You need to remember to check your answers when you have a fraction in your equations, okay? When you have a fraction in your equations. Next one here. Once again, you can see that our two denominators are exactly the same, and so the LCD will also be that same thing, okay? Just like in the last problem, when they're both of the denominators are the same, the LCD will be that same thing too. And so, as I mentioned a few minutes ago, when you have a fraction and a regular term with either a plus or minus in between it like this, what you do is you multiply the fraction and the regular term by the LCD separately, like this. Please write this out so that you can do each of the three things separately here. Okay, we're going to have three more of these circles here in this problem as well. And so you want to do those carefully and separately. All right, so that's why I'm going to write this out here. And then here's what we need to be careful here. Bring down the minus. But as we've seen a number of times in the past, when you multiply just a regular term, but it's a single term, times something that has more than one term in it, what we do is we put the regular term, the single term, in front, and then we put the thing that has more than one term in it, the LCD, we put it in brackets because we have to multiply by the whole thing. And as we've mentioned in the past, when you multiply by something that has more than one term in it, you got to bracket that thing, okay, in order to make sure you multiply by the whole thing. And you have to multiply by the whole thing, okay? You have to multiply by the entire LCD. But don't write it like this. Don't write it like this, you guys, okay? This is a very confusing, okay, as far as what you do in the next step. It is true that the LCD is being multiplied by 5. You just don't want to write it in that order, okay? It's much easier to write it in this order because we're used to that kind of order where we have the term in front of the bracket. So don't write it like that. So when you have a single term being multiplied by an LCD that has more than one term in it, okay, then write it in this order and make sure to bracket the LCD, okay, so that because it has more than one term in it, so that you can multiply by the whole thing. Okay, let's keep going here. Again, that's assuming that there's no fractions here, all right? And we didn't need to make a fraction here because the 5 was not a fraction. We made fractions here because this was a fraction. Okay, you're multiplying by a fraction, you make a fraction out of the LCD. If you're multiplying by something that's not a fraction, you don't need to make a fraction out of the LCD. Okay. This last one here, just like in the last problem, if you have just a single fraction on one side of the equal sign, you just multiply by the LCD, okay? You don't need to put a bracket around this, all right? Like I said, that was just when you don't have fractions, okay? Because, well, partly the reason why just to let you know, the reason why you don't have to do that is because when you put the LCD in the fraction here, it's already implied by looking at it that the entire c minus 5 is being multiplied by the fraction. Okay, you're supposed to multiply the entire numerator and the entire denominator by the other fraction here. Numerator times numerator, denominator times denominator. At least that's what you normally would do. Okay. But as you guys know, before we actually multiply fractions together, we cancel. Okay, and speaking of that, as I told you in the last problem, okay, you need to, and I included the minus here for a reason. I'll explain that when I circled it. Okay, we'll talk about that. But again, we have 3 things being multiplied together here and 3 things here. That's usually how it's going to work. Now we do those 3 multiplications. We figure those out. But when we multiply fractions together, what do? When we multiply fractions together, we have to identify, just like we did, because we have more than one term here in these 2 things right here, the numerator and the denominator down here. Because you have more than one term in a couple of places right here, it's not the same thing as these 2 things here where you just had single terms in all 4 places here in those 2 fractions. Okay, when you have more than one term, you got to be a little bit more careful. All right, as you guys know from 8.2, when we multiplied fractions, if you have more than one term in any of the 4 places here, you got to factor first. Identify your factors. That's why I underlined all those things, right? Identify your factors after you factor, and then you'll know what to cancel. Okay, you can cancel single terms with single terms. You can cancel multiple terms with multiple terms as long as they're exactly the same, or they have that, you know, that, and you're not going to see this here in this section, but that same term opposite sign thing like we had with h minus 12 and 12 minus h. Okay. But remember, you don't ever cancel a single term with part of a multiple term. So you don't cancel this 3 right here with this 3 because this 3 is part of a multiple term factor and this one's a single term factor. I just want to make sure you're canceling correctly here because we're revisiting the whole canceling concept right now. Okay, and so I won't go through every single little detail that we did back in 8.2. Let me know if you have any questions about it, okay, as we think about this again, as we need to use it here. But, yeah, don't cancel a single term with a multiple term. Okay, don't cancel part of a multiple term factor with a part of another one. Don't do 4 and 2 right here. You got to cancel the entire multiple term factor or you don't cancel it at all. Okay, so some details there to help you remember. So here's the good news. Typically in these problems that we're doing right now, you're not going to have to do the factoring part. You just need to identify your factors. Everything should already be factored unless you do something different than what's normally done. Everything should already be in factored form here. Okay, c minus 5 is prime, c minus 5 is prime. So again, it's already factored as far as it'll go. These are single terms, so they're just single factors. All right, and so we can cancel these since they are both multiple term factors here, and they're the same, and you get 1 and 1. Once again, just like in the last problem, you see that there? You got 1 times 1 on the bottom. That's what you want. Okay? 1 times C is C. 1 times 1 underneath that, but you don't need to write the 1 underneath that, as we mentioned in the last problem. Okay? Now, in the next part here, when you have, as we've seen with linear equations in previous sections when we've done those, let me just give you a visual of that. Okay. Here's a good one right here. This is back from the linear equations section. When you have some terms in front of the -5 here, no brackets here, just some terms, and then you got -5 times a bracket, we don't just distribute the 5, we distribute the -5, right? And so that's the same thing here, okay? We've got this thing right here in front of the -5, and then you've got the bracket. No fractions here, though, okay? So no canceling needed there. But when you have this thing here followed by -5 times the bracket, you do the same thing we did in the linear equation section, chapter 3, is we just distribute the -5. So we get -5c plus 25, like that. Okay, you're distributing not just the 5, but the -5. That's why it's so important to not write it like this up here. Okay, we're used to distributing when it's written like this. Okay, last part here. C minus 5, C minus 5. Again, those are prime. All right. So you don't need to factor them. Again, usually everything's going to be either a single term or it's going to be like C minus 5. It'll have more than one term, but it'll be prime. So all your numerators and denominators, again, will either be single term or will be prime, usually. Or sometimes you'll have like multiple brackets inside of a numerator or denominator, but the brackets will be prime. All right. The point is that you typically aren't going to have to factor. You just have to identify your factors, like we did in 8.2. Okay, like we did, and then that way we know what to cancel. Here, what would we cancel? We would cancel the C minus 5 and the C minus 5, and we get 1 times 20, and again, like we want, we got 1 times 1 on the bottom. So 1 times 20 is 20 over 1, and so that would just be 20 over 1, and you just have to write 20. So we did it. That's the toughest part of the problem, is making sure you do that correctly, but now we've got a nice normal linear equation. Okay, there's no c squareds right there, so it must be linear. And so there's no parentheses. All right, remember when we solve linear equations, we clear the parentheses. There's no parentheses. Then we combine like terms. Okay, then what do we do after we combine the like terms? We then have to move the 25 and the 20 to the opposite side of where the C term is, right? Okay. And then we then divide out, right? Negative divided by negative is positive, so the answer I get, at least initially here, is 5/4. But what's that thing that I always have to do when I'm solving a fraction equation? Okay, I need to take that answer and plug it into the two denominators up here to make sure that they're not 0. They could be any number in the world and it's fine, as long as it's not 0. So this one right here and this one right here, they're the same denominator, right? They're C minus 5. And so what is, if I plug in the 5/4 into those denominators, I get 5/4 minus 5. Okay. Now, I don't care what this is equal to. I don't care if you figure out what this is equal to. As long as you know that it's not 0, all right, that's all that matters. So, no, you don't have to figure this out as long as you know that it's not 0. We know that this is not 0. I know that this is not 0. Let me tell you why I know that. It's because when you subtract two numbers, the only way that it could be equal to 0 is if the two numbers that you're subtracting are the same number. You know, like 8 minus 8 is 0. 6 minus 6 is 0. 1/2 minus 1/2 is 0. Okay. These are not the same number, so there's no way that when you subtract them, they're going to be equal to 0. And so that's all we care about. As long as the denominators are not 0, go ahead and keep that answer. All right. If it was equal to 0, then we would throw the answer out, and then I will show you how to handle that situation. Don't worry. Okay, we'll get to that. All right, but this problem is fine. So let's move on. This is where the denominators get a little bit more complicated. Not anything we haven't seen before, though, but still. Problem C. Notice, and we saw this back when we did LCD before, all right, if you have more than one term in your denominators, okay, and they're not all the same denominator this time, so you can't just jump right to the LCD answer like we did in the last couple of problems. But if they've got more than one denominator, then we have to what? We have to factor first, like we did in 8.3 right here. Okay, when we learned how to figure out the LCD, you have to factor first. Okay, identify your factors and then figure out the LCD that way. Okay. Now, t minus 4 and t plus 4 are already prime. The GCF is 1. It's got two terms with t to the first power, okay, which means that it's not going to factor, as we've talked about before. How about t squared minus 16, though? T squared minus 16, that does factor, right? That would be t minus 4 and t plus 4. T squared minus 4 squared, right? We know that formula from when we learned how to factor two terms back in 7.4 if you want to review that. Okay. So that gives me two factors here. So we have four factors here that I underlined. They're all multiple term factors. Let me show you a good example of, just as a reminder of how you handle that. Back in 8.3, here's four red factors right here. In other words, four multiple term factors. All right, what we did was, if there's no single term factors like there is here with W and 7W, okay, we'll visit that in a moment here as well. We'll review that. But if they're all multiple term factors, you just put what? You put all of the different ones into the answer, okay, unless it's one of those problems where it's the same bracket twice in the same denominator. And that's not going to happen here, though, normally. You just put all the different ones in the answer. So we have a total of four red ones here, or multiple term ones, but there's only two different ones, right? T minus 4 and t plus 4. So sure enough, the LCD will then just have those two multiple term factors in there. T minus 4 and t plus 4. Since they're being multiplied by each other, make sure to keep them in brackets because they have more than one term, and you're multiplying them. Okay, so there's your LCD right there. Okay, this next step is a pretty big one here as far as the amount of stuff you got to write. Please be patient and don't try to cut corners here or take shortcuts, all right? That's how you make a mistake on this, all right? I've done that in the past as a student and it cost me, okay? Please just do what we've been doing. Actually, you know what? I need to explain one thing here that's a little bit different. When you have two fractions, we haven't seen that yet. When you have two fractions with either a plus or a minus in between it, in this case it's minus, you multiply the LCD by both of those things, keeping the minus sign in between. So I multiply the LCD, I make it into a fraction because we're multiplying it by a fraction just like before. I then bring down that minus sign in between, and then I multiply the other fraction there on that side of the equal sign by the LCD also. Like this. Then bring down the equal sign. That always stays in the same place there. Then we take this right here, and just like in the last couple problems, when you have just one fraction and that's it, on one side of the equal sign, you just multiply the LCD by that. Go ahead and factor keep the t squared minus 16, keep that in its factored form there, all right, because we need to factor the top and the bottom, okay, when we do the canceling anyway. And as long as you remember to put all of the denominators in their factored form here. These were already prime, these two denominators, but this one, put it in its factored form. As long as you do that, then what I promised you earlier should hold true, that you don't need to factor anything else, okay, as you go through and you multiply these three things together. These three things together right here. All right? And that's what we're going to do here. Just like we did in the last two problems where you got the three things I circled and we multiplied them together. It's just that this is a little bit bigger this time. Okay, a little bit bigger problem. All right? Everything's already factored like I promised. All right? So you just have to identify your factors here. You just go ahead and do that now to get that out of the way. I'm doing my multiple term factors, my single term factors, just like I did in Chapter 8 when we learned how to do that in the fraction chapter. Okay. And so one circle at a time here. Again, don't cross over the minus sign or the equal sign to cancel. All right. Stay within each circle here. You can cross cancel. What can I cross cancel here? I can cross cancel the t minus 4s right here. Let's talk about that right now. What do we got left? We got left t plus 4 times 1. Well, when you have t plus 4, when you have anything times 1, and actually there's another 1 here too, but anytime you multiply by 1s, what happens? Nothing, right? Okay. And so it's just going to be t plus 4. In fact, when you multiply by 1, as I also mentioned in the fraction chapter, if you multiply by positive 1 and that's it, not negative 1 or 2 or 3, but just positive 1, you can actually get rid of the brackets there too. So it's just t plus 4 over 1 times 1. That's what we want every time, right? 1 times 1. We got that again, all right? Now bring down the minus sign here, okay? And then what? Then on this part here, you have the t plus 4s cancel, and that's it, right? That's all that cancels. Now here's where we got to be careful. What do we got here? This is very, very important. Listen to this. This is one of the tougher parts, but you can get this here. Just listen closely. If you end up with, and this is not including the 1s here, because we know that when we multiply by 1, it doesn't change anything. Not including this 1 right here, what do we got left on top? We have something with 2 terms in it times something that's just 1 term. When you get 2 terms in a denominator, multiply by 1 term in the other denominator. Similar to what we saw up here, where you had the single term times 2 terms. Put the single term, just like I did here with the 5, put the single term in front, and then the multiple term thing, keep it in brackets, or put it in brackets if it's not already, but keep it in brackets if it already is, like with the t minus 4. But put the single term in front, 9. I know it's not currently in front, but you know that when you multiply things together, you guys, you can change the order. And it's important to change the order here because you want the single term in front of the bracket that has more than 1 term in it. That way you can, we're used to seeing things written like that, like I mentioned a few minutes ago, where you got a single term in front of a bracket, and the bracket has 2 terms in it, and you distribute. Don't distribute yet, please. Okay, you don't want to go too fast. That's how you make a mistake. Okay, just write this down with the single term in the bracket. Just bring it down. Don't multiply it yet when you have a single term times a bracket. Bring it down. Okay, just like up here. Notice I just brought it down. I didn't multiply until the next step. I just said the single term times the bracket, and then I multiplied in the next step just to make sure that I did it right. Okay, so that's exactly what I did. So single term times 2 terms, okay, put the single term in front, all right, after you're done canceling, all right, bring down the equal sign. Over here, 2 things cancel, right, the t minus 4s and the t plus 4s cancel right there, all right, so all you have left besides the 1s right there is the 8. You have 1 times 1 times 8 and 1 times 1 times 1 on the bottom. Again, it doesn't matter how many 1s you have on the bottom. As long as they're all 1s being multiplied, that means the denominator is going to be equal to 1, and the denominator will go away, right? That's what we want. So that it's 8 over 1, which is 8. So once again, we have what appears to be, and we have a bracket here that we still need to clear out, but even after I clear out this bracket, it's still going to be linear, isn't it? You're not going to have a t squared term, are you? So We know, therefore, that this is a linear equation. Since it's a linear equation, I need to clear out the parentheses first. And then I combine like terms. Negative 8t, the 4 and the 36 become 40. Then I need to move over the what? I need to move over the 40 with the 8, because they don't have the variable in it. And now you have what we want to have, which is the single variable term and a single constant term. Single term on each side with the variable only on one side. That's the step where we divide out, right? What is negative 32 divided by negative 8? Negative divided by negative is positive, so we get positive 4. Again, do not circle that yet. Okay, in fact, we got a problem here, don't we? Remember I said when we have a fraction equation, we got to check our answers by checking the denominators. Okay, and when we check those denominators, the first one, when I plug it into the first one, that's equal to 0. So if at least one of the denominators is 0, then this problem is, or this answer is not going to work, because you can't have a 0 denominator. Okay, remember, the answers are supposed to make the equation true. The equation can't be true if the answer makes one of the denominators equal to 0, because that's not even a number. Okay, so that's why I was saying you got to check to see if the denominators are equal to 0. All right, so if at least one of your denominators in your original equation is equal to 0, when you check your answer, here's what you do. You cross out that answer, and if that's the only answer you got, then that means there are no good answers. And so therefore we say no solution. Okay? Because this method I'm showing you will always give you all the good answers. It always will. And so if you check your answer and it doesn't work and there's nothing left, that means there is no solution, because if there was a solution in reality, then this method would have given it to you. So if there's nothing left after you check your answers, that truly means that there is no answer. Okay. So check your answers, and if there's nothing left after you've checked them, then you say no solution. And you have to say those two words. Don't forget that. Otherwise, I won't be sure that you understand that there really is no solution. Okay. All right, problem D. Once again, we have to factor our denominators. If at least one of them has more than one term, you have to go through that process. A couple of them do, the first one and the last one. Y plus 2, however, is prime. GCF of 1, 2 terms with y to the first power. That's prime. Single terms don't need to be factored. Okay, that's just a single factor, that's it. But this one has a GCF. We get 4 bracket y plus 2. And as we just mentioned a moment ago, y plus 2 is prime, so that's as far as that factoring goes. Okay. How do you figure out the LCD based on what I just wrote down here? Now that I've factored everything. We saw a problem back in your LCD section, section 8.3 again, where some of them were single term factors like W and 7W, and then some of them were multiple term factors. There's 4 of them here. Okay, when that happens, you got to look at the single term factors separately from the multiple term factors. In other words, you need to look at the 4 and the 4 separately from the y plus 2 and the y plus 2. Okay, and then what you do is with the single term factors, you look at what is the least common multiple of 4 and 4. Well, if both of your single term factors are exactly the same, okay, the least common multiple is going to be that same thing, 4. But you also got to look at the multiple term factors. Remember, you have to put all of the different ones in the answer, just like we did over here. Okay, we have 4 multiple term factors over here. We put all the different ones into the LCD. There's only one different one here because they're both the same. And so we just put that in there one time like that. And so that's the LCD. Again, very similar if you want to go back and review it. Very similar to problem D in section 8.3, where you've got to look at the single term factors W and 7W separately from how you look at the multiple term factors. Okay, we did a similar one over here as well in problem C in that section. 8 and 6, we got 24 out of that. And then the 3x minus 2 and 3x minus 2, you just put that into the answer as well. Okay. All right. So we got to multiply the LCD, keep it in its factored form there. Don't distribute out the 4 because you want it to be factored so that you can cancel. But like I said, if you have just a single fraction on one side of the equal sign, you multiply that by the LCD over 1. Okay? And so that's what I did on this side of the equal sign. I multiplied this fraction by the LCD. Okay? Then remember, when you have two fractions with either a plus or minus in between it, okay, in this case it's a plus, you multiply, and I need to write a little bit smaller here to fit it on the page. Okay, I'll zoom in here a little bit more so you can see it better. But you need to multiply the LCD by both of those things, both of those fractions, keeping the plus in between. So let me do that. And oh no, I ran out of space, didn't I? Okay, let me, let's see, what can I do here? Again, you don't have to erase it if you've got enough space. I just need to do that for my own sake here on the paper. I'm going to try to squeeze it in here. Bring down that plus. There we go. Now, like I said in the last problem, don't write down 4y plus 8. Write down what it factored down to be, because you're going to need it to be in factor form in order to cancel anyway. Okay, so I'm sorry that got kind of smaller on the end. Let me zoom in a little bit more. There we go. And so then let's go ahead and first of all realize that we have 3 multiplications to do just like in the other problems. Okay. Let's identify our factors in each one. Okay, just the same way we did back in the fraction chapter. When you have a single term being multiplied by a bracket and that's all you have in that numerator denominator, then that's going to be 2 factors. That's why you see 2 things underlined here, for example. Like that kind of situation pops up a lot in this problem here, where you got the 2 factors, single term times a bracket. But again, doing this underlining thing helps us realize what we can cancel and what we can't. In this first problem here, we can cancel the y plus 2. All right. And not including the 1 here. What we have, just like in the last problem, is we have a single term in one of the denominators, or one of the numerators rather, and a multiple term thing in the other one. So what did we say in the last problem? We said that when that happens, you put the single term first. In this case, it's first anyway, but so we don't have to change the order, but that you want to do that either way. Put the single term first, and then if the other denominator has more than 1 term, you got to make sure to bracket that if it's not already bracketed, because you have to multiply by the entire other numerator. So if it's got more than 1 term, bracket it if it's not already. Okay. Kind of similar to up here when we had to multiply by the LCD, and it didn't have a bracket in it, but because it had more than 1 term and you were multiplying it by something, -5, we had to bracket it. Same idea. Okay, same idea down here. Next one. The 4's cancel on this one, right? And once again, we achieved our goal of having 1 times 1 on the bottom. But again here we have what? We have a single term in one numerator, y, and then we have a multiple term, not including the 1. We have a multiple term, y plus 2, in the other one here. Bring down that equal sign, by the way. But yeah, we have the single term. We want to write that first, and then the multiple term thing after that. Keep it in brackets. bring down the plus that's in between those two. Just like if you had a minus in between these two things we circled, you'd bring that down. Okay. And then here, both the 4s and the y plus 2's cancel, don't they? And so everything's just 1s. 1 times 1 times 1 on top, 1 times 1 times 1 on the bottom, and of course that's equal to 1 over 1, which is equal to 1. And so, just like in all the other problems, we do the 3 circles here. The fractions should all go away. We should have nothing but 1s being multiplied on the bottoms of each one of these 3 circles here. That makes the denominators go away. It makes the fractions, therefore, go away. And now we have a normal equation. However, this one, even though it initially looks like it's linear, if I clear out my parentheses, what do we get here? We get a quadratic equation because y times y is y squared. So you've got that y squared term in there. Okay. Now, unless it's one of those problems where you do the square root property, okay, you wanted to clear out your parentheses first anyway. Okay. So that was fine to do that. Now, this is one of those problems. Remember I told you at the end of the last video that when you're halfway through a problem and all of a sudden a quadratic equation pops up and it wasn't there before, you can then choose what method you want to do to solve that. Okay, so if we do that, I think it's pretty clear here that you don't want to do the square root property because if I try to get y squared by itself, you're going to have a variable on the other side, and we can't do the square root property on that like we talked about. So again, this is just my opinion based on what I shared with you last time, but if you're not going to do the square root property, assuming you've cleared out your parentheses already, move everything to one side. Okay. Make sure the y squared is positive and make sure the terms are in descending order. Okay. So y squared, meaning the squared term goes first, and then the y to the first term after that, and then the 9. There it is right there. And then we try to factor that. If it doesn't factor, then you can fall back on the quadratic formula as another option. But this does factor. The Berry method tells me that since 1 times 9 is 9, and since we needed to add up the negative 10 in the middle there, the two numbers that I'm going to use are negative 1 and negative 9. You don't need to do the last step of the Berry method here. You do not. Okay. Because that's not going to change the brackets like it sometimes does. We then set these brackets equal to 0. Okay. And what are those two answers there? If I solve those two equations, what do I get? I get y is equal to 1 if I move the 1 over to the other side, and I get y equal to 9 if I move the 9 over to the other side. Don't circle it yet, though. Remember, after you get the variable by itself, what do we do again? We go back into the original equation, and we check to make sure that those two answers do not make any of these denominators 0. Okay, let's start out with the 1. If I plug the 1 into this denominator, it's equal to 1 plus 2. That's not equal to 0. That's equal to 3, right? If your denominator does not have a variable in it, you don't need to plug into it, okay? 4 is always going to be 4 because there's and therefore it's fine, just so long as it's not 0, okay? 4 is always going to be 4 because there's no variable there to change it. All right, so you don't need to plug into the denominators that don't have variables in it, just the ones that do. And so I plug the 1 into this one. 4 times 1 plus 8, that's equal to 12. Multiplication before addition, right? Okay. 4 plus 8 is equal to 12. So number 1 is fine. If I plug in the number y equal to 9, if I plug that in, it's also going to be fine. Let me show you why. 9 plus 2 is 11. 4 times 9, and again, you don't have to plug it into this one, but 4 times 9 is 36, plus 8 is 44. So again, none of the denominators are equal to 0. Final answer, y equal to 1 and y equal to 9. Okay, so that concludes these 4 problems. Okay, you can see that on the second page here, there are 3 problems. Please try those. Okay, don't be thrown off by that single term right there. We haven't seen that before where it's just a single term on one side. Okay, just multiply that term by the LCD. All right, just like we had single terms in a couple problems on the first page, you multiply that by the LCD too. Okay, the other two problems, everything's fractions. So you just multiply by each of the three fractions in each one of these. But figure out your LCD first. Okay. And hit the play button when you're done with that, and we'll see how the answers come out. All right, let's take a look at number 1 here. Our denominators are just 9 and 4, just a couple of constant single term numbers there. The LCD, therefore, is you just take a 9 and you keep on listing out the multiples of 9 until you get one that works for 4 also. And 36 would be the smallest one that would work, and that's why 36 is the LCD. That's what you do if you just have no variables. You just have a couple of single constant numbers there. Okay, and we did that in 8.3 as well, at least for part of the problem. Okay, when we did the coefficients, it works that same way. So 36 is the LCD. Okay, because there's no variables, you don't have to do that thing where you try to find the largest exponent or whatever. Okay, you just have to do the same thing you normally would with the coefficients when each denominator is just a single term. Let's go ahead and take a look at what we do with 36. 36 is going to be multiplied by these two fractions, bringing down the minus in between here. Okay, it gets multiplied by the -2 on the other side as well. Sorry about all these circles. There's probably too many of them here. Let me clean that up a little bit. So, but we need to multiply those three things. All right, just like we normally do, those three things separately. In the first one here, the 36 and the 9 cancel with each other. Okay, because those are both single-term factors. Notice I did my underlining in order to identify, at least on the fraction ones. You don't have to do it here because they're not canceling when there's no fractions. But on these two that I circled, I did my underline so I know what I can cancel and what I can't. On this one, I once again end up, after I'm done canceling, I have 1 over 1. I have 1 times 1 on the bottom. That's what I want. But on the top, I have a single term times a denominator or numerator that has more than one term. And so I do that same thing I've been telling you about, where you put the single term in front of the multiple term and make sure to put the multiple term thing in brackets. Okay, because it's being multiplied by the 4 and it's got more than one term in it. Bring down the minus sign. Similar thing happens here. The 36 and the 4 cancel. We get 9 and 1. So we end up with 9, and again, bracket the x minus 1 because it's got more than one term. Okay, and bring that down. Very similar to this part. Okay, 9 in front of the bracket. And then here you don't have any canceling to do because there's no fractions. Just multiply it, you get -72. And what this leads to is a linear equation. No fractions anymore, though. Okay. So then we solve that linear equation. We distribute out the parentheses first. We combine like terms. We move over to the 13 with the -72. Okay, and then when we divide out, yes, we do get a fraction. That's okay. All right. And there we go. That looks like a negative. There wasn't. Okay. It's -85 over 3. Okay, notice that there's no variables in any of the denominators. You only have to check the denominators that have variables in them. And so if none of your denominators have variables in them, then you don't even need to check your answer at all. It's just the ones that have variables in it that could potentially be equal to 0. And so you don't need to check that fraction there. All right, just circle that. There's no doubt that that's going to be fine as long as you did all your other work correctly. All right, don't need to check when there's no variables in the denominators. Next one. X plus 3 and x minus 3 were prime. X squared minus 9 is equal to this right here. Okay. And so the LCD, kind of similar to that t minus 4, t plus 4 problem on the front, the LCD is going to be x minus 3, x plus 3. Those are the two different multiple term factors in your denominators. So we multiply these three fractions by the LCD, and you can see I did all my underlining to make sure that I know what I can cancel and what I can't. Okay. Here the x minus 3's cancel, and once again you get a single term, 3, not including the ones. A single term being multiplied by a multiple term numerator, and so you got to put the single term in front. Keep the multiple term numerator in brackets. Bring down the minus sign, and then the same thing happens here. The x minus 3's, I'm sorry, I wrote that down wrong. This was x plus 3. Let me fix that. I apologize. So that, I canceled the wrong thing right here. This was supposed to be x plus 3, and it cancels with the x plus 3 down here. And so what was left in the first part here was x minus 3, which I already had written down, but the work was wrong up here, so I fixed it. So the x plus 3's cancel there. We get this. The x minus 3's cancel here. Let me do that. And we get, again, a single term in one numerator and a multiple term, x plus 3 in the other. And so we got to put the 2 in front of the multiple term one like usual. All right. And again, don't multiply it yet when you do that. When you have the single term times a multiple term, just bring it down and then we'll multiply it. We'll distribute it out on the next step. Okay, you don't want to move too fast. Okay. Over here, both of the x minus 3 and the x plus 3 cancel. And we get everything's just equal to 1 except for that negative 12. So we end up with negative 12 over 1 when we multiply. And I brought the negative 12 down. So we just are left with, again, a linear equation. So let's solve that. Distribute. Combine like terms. Move over the 15 with the negative 12. My final answer, at least initially, is equal to 3, right? But why did I cross that out and say no solution? I crossed that out and I said no solution because even though it makes the first denominator equal to 6 when I plug it in, which is fine, unfortunately it makes the second denominator equal to 0, and that's why I got to toss it out. And when you have nothing left after you've checked your answers, we say these two words here, don't we? So again, it doesn't need to make all of the denominators equal to 0 in order for it to be bad. If it makes any of them equal to 0, you've got to get rid of it. So you got to get rid of the 3 then. And so we say no solution. Last one here. If you factor your denominators, y plus 3 was already prime. 8 is just a single term. Here you factor this, kind of similar to problem D on the first page. You got the two single term factors here after you factor everything. You've got the two multiple term factors, but they're both the same. So we do the same thing that we did in the front. Only difference, though, is that the 8 and the 4 are not the same. But when you have single term factors and you're trying to figure out the LCD, just like we learned back here in problem C in 8.3, you take the two single term ones and you figure out the least common multiple of those. And it was 24 in this case. But what is it when it's 8 and 4? It's going to be 8 because 8 is a multiple of 4 and 8. Okay, and it's the smallest thing that is. So you don't need to do 16 and 24 here. 8 will work for both. So we put that into the LCD. We also put the y plus 3 into the LCD. Okay, because again, you just need to put all of the different multiple term factors in there. Okay. Just like we saw here, 3x minus 2 and 3x minus 2, you just need to put all the different ones in there. So you don't need to say 3x minus 2 twice in this case. Okay. So we multiply all three fractions by that. Okay, just like in the last problem. All right. And let's see how it all works out. The first one here, the y plus 3's cancel, and we get, other than not including the 1 here, you get 8 times 2 on top. And notice here that it's just a single term times a single term. You don't have the multiple term thing this time, so you can just multiply it. Okay, in fact, that's okay to do right now. It's just when you have a single term, as we'll see in the next part here, the 8's cancel. When you have a single term like 3 being multiplied by a multiple term, if one of them is multiple term, that's when you got to be careful to bring the 3 down into the front, like we've talked about many times here in this section, and then you put the y plus 3 behind that. But if it's just 2 single terms left, okay, not including the ones, then you can just multiply. There's no confusion there. It's not going to cause any issues. All right, just do 8 times 2 equal to 16. All right. On this one, the 8 and the 4 cancel and then become 2 and 1. Okay, they're both single term factors, so you're allowed to cancel with those. None of the other single term factors cancel anymore, 2, 5, 1, and 1. But we can cancel the 2 multiple term factors there. And so what are we left with here? Again, not including the ones. We have 2 times 5, and that's where the 10 comes from right there. And once again, as we wrap up this last problem, we have a linear equation. So we do the normal steps. Distribute. Combine like terms. Move over the 25 with the 10. Okay, all the same normal linear steps. All right. Then we divide out by 3. Okay, and that gives me y equal to negative 5. Why did I circle that? It's because negative 5 does not make any of these denominators equal to 0. You don't even need to check this one because it doesn't have a variable in it. But the other two denominators, if you plug in negative 5, it'll make this one equal to negative 2. And it'll make this one equal to negative 20 plus 12, which is negative 8. So as long as it's not 0, go ahead and circle that answer. Meaning that, I don't mean the answer 0, I mean as long as it doesn't make the denominator 0, then circle the answer, okay? And so that finishes up that problem, and it finishes up this section as well. So let me know if you have any questions as usual, okay? Otherwise, you have a good day, and take care.